Hello everybody, I hope you are great. Welcome back to the second part of course. If you watch this video series for the first time, this video is the second part of front end with React, back end with C++. I recommend watching the part 1 first, then watch this video. Alright, as I have said in the first part, in this video series we are going to implement a calculator web application which has two parts. Part number 1 is calculator front end and part number 2 is calculator back end. We have implemented the front end section through React JavaScript library in the video part number 1, and we are going to implement the back end section through C++ in this video. Alright, let's implement the back end section. We are going to use restbed C++ framework to implement calculator web API. Alright, what is restbed? Restbed is a C++ 11 framework which enables us to implement RESTful web API. You can access the restbed framework through this link. Alright, we are going to implement calculator web API in the form of a JSON web API. So we need a C++ JSON library. There are a lot of JSON libraries. We have selected JSON library for modern C++. Alright, what is JSON library for modern C++? It's a single headed JSON library for C++ programming language. You will see it has an intuitive syntax. Thanks to Niels Lohmann for implementing this library. You can download this library through this link. Also, we need a cross-platform build system which enables us to build calculator web API. We are going to use CMake as a build system. Alright, what is CMake? CMake is a cross-platform and open source build system. CMake is used to build, test, and package C++ software on many platforms like Windows, Linux, and Mac. Alright, now install restbed framework. If you have a Linux machine, you can run this command in the terminal to install restbed. Otherwise, you can install restbed framework through this link. Now open the terminal and run this command. Then run the second command. Excuse me, correct the command. Alright. Now install JSON library for modern C++. JSON library for modern C++ is a single header library. You can download its header file through this link. Open its GitHub page and then go to the release page and finally click on JSON HTTP file. Alright. C++ codes need to compile, so we need a C++ compiler. If you have a Linux machine, you might have GCC. Also, you can install Visual C++ for Windows or Clang for Mac OS. If you didn't install any C++ compiler, please pause the video and install a C++ compiler. Alright, now install CMake. If you have a Linux machine, you can run this command in the terminal to install CMake. Otherwise, you can install CMake through this link. Also, if you have an Ubuntu machine, you can install CMake through a Snapcraft application by running this command. Now open the terminal. My operating system is Ubuntu 19. Sudo snap install cmake. Alright, let's implement Calculator Web API application. Open Visual Studio Code and open Web API with CPP directory which we have created in the video part number 1. Alright, in the terminal, create new directory in the Web API with CPP directory called Calculator Backend. Alright, the fundamental concept in any RESTful API is the resource. A resource is an object with a type, associated data, relationships to other resources, and a set of methods that operate on it. It's similar to an object instance in an object-oriented programming language, with the important difference that only a few standard methods are defined for the resource object, like HTTP methods get, post, put, or delete, while an object instance typically has many methods. We can consider the Calculator API as a resource. The restbed framework has a class called resource. Resource class helps us to implement resources in our RESTful API. For each resource, we must declare an object from the resource class and then implement methods of resource which we need, and then bind these methods to the resource object. Alright, we're gonna do this stuff through a class. Before implementing the class, first let's implement an interface for this class. Create a new directory in the Calculator Backend directory called include in order to place all C++ header files inside it, and then create new C++ header file called iResource factory. And now let's implement the iResource factory interface. Include memory, standard library, and then restbed library, and implement abstract function called getResource. Alright, the I letter in front of its name stands for interface, which means iResource factory is an interface class and all its functions are abstract functions. Every resource factory class must implement this interface. This interface has an abstract function called getResource. Every resource factory concrete class must prepare resource and finally deliver to its customer through getResource function. In more details, it means concrete class must create an object from resource class and then implement all functions which it needs, then bind functions to the resource object, and finally return resource object in the getResource function. Let's create its concrete class. Create new header file called calc_resource factory.h. Include its interface file and declare a new class which implements iResource factory. And override getResource function. Alright, this class has a constructor function. Also has a member object its member object is a shared pointer from resource class called _resource. Alright, we have said every resource factory must prepare an object from the resource class and then deliver it through the getResource function. Alright, we can remove this standard namespace at this point. Now let's implement its constructor. Create new C++ source file in calculator backend directory called calc resource factory.cpp. Include its header file and then implement its constructor function. Alright, every resource in RESTful API must associate with an URL. We can associate an URL to calculate a resource through setPath function. Alright, I think calculator resource URL must have 3 parts. Alright, part number 1 is the operation like add, subtract, divide or multiply, and part number 2 and part number 3 are operands. Alright, let's design this URL. First part, operation, and specify its pattern through regex syntax. Alright, let me explain this again. We have initialized the resource object to a newly allocated shared pointer from resource class. Then we have associated an URL to resource object through setPath function. This URL has 3 parts. We have labeled each part with these labels: operation, num1, and num2. You'll see we can read each part of this path through these labels. Alright, we have used a regular expression syntax in order to filter each part of the URL. Operation part must accept only add or subtract or multiply or divide parameters, which specify the calculator functionality. Num1 and num2 parts must accept only float or integral numbers, which specify calculator functionality operands. Alright, every resource object must have a handler, which is called when resource is requested by client. We can set a function handler through calling set method handler. This function gets 2 arguments. First argument is the HTTP method set this argument to get HTTP method, and second argument is the function handler. Alright, the function handler must get an object from session class. Alright, I'm gonna implement a function handler in the calc resource factory class. Now suppose we have a function handler called get handler. Call this function in the lambda expression and pass the session object to this function. Alright, now let's declare this function in the calc resource factory class. At first, declare this function in the header file, get handler, and then implement this function in the source file. Alright, every time resource is requested, get handler is called and an object is passed to the handler called session. Through the session object, we can get any information about request and send results to the client. Alright, I almost forgot. Pass the ampersand symbol to lambda capture argument. Alright, let's implement get handler function. Before implementing get handler function, add a new function called get path parameters in order to get values of labels in the URL which is requested. Add this function in the header file at first. We need tuple standard library and also a string standard library, and declare this function in the private section. Alright, this function must get the values of labels in the path and then return these values as a tuple object. Alright, now let's implement this function. At first, get request object from session. Then we can get the path parameters from request object. Call the get path parameter function and pass the label as argument. Alright, operation value and then number 1. Also, we must convert the number 1 and number 2 from a string to float numbers. We can use ASCII to float function. Then number 2 and finally we must return a tuple object. Alright, now we can use get path parameters in the get handler function. plus the session object. Alright, did you see this feature before? This feature is called a structured binding, which was added in C++ 17 standard. Alright, it's amazing. Alright, now we must calculate the result at this point. Implement a new function to calculate the result. Add a new function to the header file called calculate. This function must get number 1, number 2, and operation. Let's implement this function in the source file. Right, it's very simple. If operation equal to add, then we return num1 plus num2. If, or we can say else if operation equal to subtract, return num1 minus num2. Else operation equal to multiply, then return num1 multiply num2. And finally else if operation equal to divide, return num1 divide num2. Alright, now we can call calculate function in getHandler. Pass num1, num2, and operation variable as argument. Declare result as a const variable. Alright, the next step, we must create a JSON data structure and put the result inside it in order to send to the client. Now let's create the JSON data structure. Alright, we must copy the JSON library which we have downloaded. In the terminal, copy the JSON header to include directory. Alright, we're gonna add a new function to convert the result variable to the JSON data structure. Alright, let's add the new function. In the header file, declare the function and implement this function in the source file. Alright, we must include some header files. Include ssstream library to format the result, and include iomanip, and finally include JSON library. Alright, in the two JSON function. First create a string object and then push the result variable into it in order to format the result variable. Then create a JSON data structure called JSON result. And declare a new variable inside JSON result called result and set it to result str string. Alright, as you see, JSON data structure in the JSON library has a very intuitive syntax. Alright, and finally return JSON result and call the dump function in order to convert data structure to a string. Alright, now we can call the toJSON function in the get handler. Alright, something wrong at this point. JSON library has a namespace called nails lumen. Alright, now we must send data to the client at this point. We can do this by calling the close function of session. Call the close function. We can pass three objects to this function: HTTP status code, message body, and finally pass the HTTP headers. Set the content lengths of HTTP headers to lengths of content. Alright, now it turns to implement get resource function. Just return resource object. Alright, now we are going to publish a calculator resource through a web service. The Respite framework has a class called settings to initialize settings of a web service. Alright, we are going to implement a new class in order to create settings of calculator web service. Alright, we start off by designing its interface. Create new header file in include directory called iService settings factory and implement new interface. This interface is similar to the resource factory interface. We can abstract these interfaces more, but it's beyond this course. The iService settings factory interface has an abstract function called getSettings. It's an abstract function. Alright, every concrete class which implements this interface must prepare and create web service settings and then deliver settings through the getSettings function. Alright, I almost forgot. Add virtual keyword in front of abstract function. Alright, now it turns to creating a calculator web service settings factory class. Alright, create new header file called calc service settings factory.h. Include its interface and implement calc service settings factory class. This class must implement iService settings factory interface. Declare a constructor and also override getSettings function and declare a member object from settings class called settings. Alright, let's implement its constructor. I think its name needs a S letter at this point. Right, correct it. Now we'll implement its constructor. Create a new source file. Include its header file and implement its constructor. First, initialize settings object. Then set port. We're going to run the web service on 8080 port. Then set default headers. First header is connection. Set to close and setting HTTP header default header is access control allow origin, set to a star. This header is set to prevent CORS errors. For further information, you can Google this error. Alright, finally implement getSettings function. Return settings object. Alright, I think I've dropped a letter in source file names. Rename its source file. Alright, now we are gonna implement calculator web service. The Respite framework has a class called service. This class helps us to create web services and publish resources. We are going to implement a new class to implement calculator web service through this service class of Respite framework. Alright, let's start by designing the interface. Create a new interface called iService.h. declare iService interface. This interface only needs a function called a start in order to start web service. Alright, let's implement its concrete class. Every concrete service class which implements this interface must get resources and settings objects and then initialize a web service. And when the start function is called, it must ignite the web service. Alright, let's create the concrete header file. Create new header file called calc_service.h. Include its interface and also interface of resource factory and interface of settings factory, and declare concrete class called calc service. Declare a constructor and inject its dependency, resource factory and settings factory. Alright, we are going to inject the resource factory and settings factory to the calculator service because calculator service needs them. It needs to resource factory in order to get resource and publish the resource, and it needs to settings factory in order to get the settings and set the web service. Alright. Override a start function in private section. Declare an object from service class called underline service and an object from service settings factory interface in order to capture it. Alright, let's implement its constructor. Create its source file called calc_service.cpp. Include its header file and implement its constructor. Alright, in the constructor, first capture settings factory, and then you can publish the resource through calling publish function of service object. We can get the resource object from resource factory. Finally, implement start function. We can call the start function of service in order to start web service, and we must pass the settings object to a start function. Can get settings object from settings factory. Alright, now it's time to connect classes together. Create main.cpp file, cpp, and include concrete classes, calc resource factory, then calc service settings factory, and finally calc service. Declare main function, declare an object from resource factory, and then settings factory, and finally make an object from calc service and inject its dependency. First resource factory object and then settings factory object. Now call the start function in order to start web service. Alright, it's very simple. As you see, if software is developed in a modular manner, everything becomes simple, beautiful, and self-expressive. Congratulations, you did it! Now let's compile and build the calculator web API project. We are gonna build this project through CMake. Now create a new file called CMake lists.txt in calculator backend directory and add these commands to this file. CMake minimum required version 3, then call the project function, then call add executable function, and add the compilable files main.cpp, calc resource factory.cpp, calc service.cpp. Let me correct it. Then calc service settings factory.cpp. Alright. Then link the project with Respite library, and then add include directory, finally set C++ standard property to the target. Alright, now you can build project through running this command in the terminal. CMake and pass the -h parameter with source directory in calculator backend directory, and then pass the -b tag to the build directory. calculator backend and build directory. The dash h points to the source directory and dash b points to the build directory. Alright, run this command. It causes configure the project, and finally we can build the project through running this command cmake build and pass the build directory, calculator backend build directory, and then set target to all and config to release. Run this command. It causes build the project. It's completed. Alright, now we can run the project. Calculator backend build and calculator API. The backend API is run, and then create new terminal and also run front-end application. Congratulations! Now you can work with calculator. 8 multiply 5. Press equal button and you can see its result, and then divide by 4 plus 2.6 and then equal button. Alright, it worked. The calculator project is completed. I hope you enjoyed. If you like this video course, please subscribe. Thank you. See you later.